This is TechKnow, a show about innovations that can change lives.
The science of fighting a wildfire.
We're going to explore the intersection of hardware and humanity, and we're doing it in a unique way. This is a show about science by scientists.
TechKnow investigates Katrina 10 years after the storm.
During Katrina, a large amount of water rushed in from the Gulf.
The walls were engineered to stop Mother Nature. They failed.
Do you think that New Orleans is safer than 10 years ago?
Now rebuilt, higher, stronger, billions of dollars spent. New tech to predict storms.
We'll be able to make measurements of the winds as they change very quickly.
But is this city safe?
Do I feel 100% safe? No.
Marita Davison is an environmental biologist.
As the waves are coming in, explain to me what's happening.
Tonight, she goes inside the lab to bring the latest research that could stop the next superstorm. And I'm Phil Torres. I'm an entomologist.
So how did Katrina change the residents' attitude towards nature?
Now, TechKnow in New Orleans. Katrina, 10 years after.
I'm here in Jefferson Parish in the exact spot that was submerged back in August 2005. Now, I'm 6'2", and if I stretch my hand up to this height, triple that. That's how high some of the floodwaters were in some neighborhoods here in this area. Now, while the waters are long gone, the issues are not. TechKnow's Marita Davison has spent a week here in New Orleans. Now, Marita, you've been piecing together what went wrong from a science and engineering perspective.
And Phil, you said it. This community was devastated when Hurricane Katrina hit. Now, in the 10 years since, scientists have made significant improvements to the system. These are coming together to form multiple lines of defense that reduce the risks from another Katrina-like storm. Let's take a look.
This area has been vulnerable to storms like Katrina since 1,200 years ago.
Katrina was really a wake-up call to the Corps of Engineers.
What Katrina did, it sort of helped it because it brought the eye to what's happening when you destroy things. If we don't repair the things that protects us, in 80 years, the city of New Orleans would be underwater.
A decade later, Hurricane Katrina is still considered one of this country's most deadly storms. In August 2005, Katrina claimed more than 1,800 lives along the Gulf Coast, leaving 80% of New Orleans underwater. When Katrina hit New Orleans, she was only a Category 3 storm. But in many places, the city had only one line of defense: levees, made of earth. In 50 different locations, those levees failed. In the 9th Ward, major levee breaches and overtopping caused entire homes to be swept away, killing hundreds, while others scrambled to rooftops for safety. In St. Bernard Parish, more than 5,000 children were reported missing during the height of the storm. And the neighborhood of Lakeview, located right next to a major storm defense system, was basically washed away. 1 month later, the head of the Army Corps of Engineers, Colonel Carl Strock, was forced to testify before Congress for his agency's role in the disaster. Since the 1920s, that branch of the military has been responsible for the city's structural defenses. 1 year later, they released a 6,000-page report publicly accepting responsibility for the levee failures. Colonel Carl Strock said, quote, "We had a catastrophic failure, and words alone will not restore trust in the Corps." Do you think that New Orleans is safer than 10 years ago?
I would say New Orleans has much more robust flood defenses than it did 10 years ago, unquestionably.
Mike Park is the Chief of Operations for the Army Corps of Engineers New Orleans District. He was born here and in charge of cleanup and rebuilding after the storm.
Construction is in progress.
The Army Corps has been working non-stop to mitigate storm damage. Their solution, still 1 year away from completion, is the new Storm Risk Reduction System. This new system surrounds 4 New Orleans parishes. It now includes 133 miles of levees, flood walls, surge barriers, and pumping stations. This innovation, the rappel system, is also one of the new solutions being tested by the Corps. It's essentially a giant plug. When there's a breach, it can be inflated on shore. Then engineers float it towards the breach, hoping the pull of the water will wedge the plug tightly enough to slow the leak. During Katrina, the 17th Street Canal was the site of one of the worst levee breaches. Today, it's one of the last pieces in the $14.5 billion defense system. Now, have the design criteria been more strict, more stringent this time around?
Yes, the system design has really evolved based a lot on the lessons that were learned from Hurricane Katrina.
For example, an eye wall design was previously used on floodwalls, which was a simple straight steel beam driven into the ground. Now, T-walls made of concrete and steel provide more support around the base of the walls. The entire system is all designed to reduce the risk associated with a 100-year storm, like Katrina, down to 1% each year. How should the New Orleans public interpret that? Should they feel safer?
The system that's in place now is the most robust system for flood risk reduction that we've ever enjoyed. But they should not be complacent. There's always a residual risk of flooding from storms that exceed that design.
The flooding at 17th Street Canal in 2005 is a good example of the tremendous engineering challenges the Corps faces. What exactly went wrong here?
The storm surge 10 years ago was able to penetrate up into this 17th Street drainage canal, and the eye wall failed, releasing a flood that came into the community.
After Katrina, the Army Corps of Engineers began to build additional lines of defense at the 17th Street Canal, a flood wall, more pumping stations, and higher levees. Southern Louisiana is hot and swampy, so constant soil erosion and sediment displacement, as well as the fact, in some places, New Orleans is up to 800 feet below sea level, is why this city is so naturally prone to flooding.
Yes, I'll take off to the south with a north departure.
At 1,000 feet, flying just on the outskirts of New Orleans, it becomes very obvious how a large surge of water would have caused the devastation that we saw during Hurricane Katrina.
Most of South Louisiana is new land. There's no stones down here. That's all sediment.
Foster Krappel's family has lived on this delta for generations. About 50 miles outside New Orleans in Port Sulphur, they've seen their share of flooding, especially during Katrina.
The delta is 85% organic. It's plant growth and decay.
Try to build a sound structure on that, but Foster Krappel did anyway. He bought the old Woodlands plantation from auction and turned it into a bed and breakfast. Woodlands is also outside the Army Corps' new storm risk reduction system, and Foster is actually glad. His common sense approach to flooding may seem radical to some, but Foster Krappel is part of a movement looking to nature for protection.
I think we should lower the levees, front and back, raise our houses, and reintroduce the river to the delta.
By lowering the levees, as you suggest, you'd have to deal with flooding more regularly. Are you willing to deal with that?
I am. I'd rather deal with the annual flood from the Mississippi River than the big floods that come from the storms.
Foster says trying to overmanage the river has caused waterways to become too salty, killing huge chunks of the delta that used to naturally buffer people from storms.
First, we clear-cut the cypress swamps. Then we built the levees. Then we harvested most of the old natural oyster reefs. And then we started drilling and dredging and drilling and dredging for oil and gas. I definitely need air conditioning. I like to travel. I love oysters, but at the same time, I also would like to be protected from storm surges.
Coming up on TechKnow, scientists are taking Foster Krappel's approach seriously.
One of the problems was we didn't have vegetation in any of our models.
Studying how coastal wetlands can make southern Louisiana safer.
So we knew that the wetlands were good for dissipating energy and it would be good for the project, but we couldn't quantify it.
We want to hear what you think about these stories. Join the conversation by following us on Twitter and at aljazeera.com/techknow.